us see another topic, which is circular motion. This is quite different from linear motion. In circular motion, we say that this is a motion described by an object in a certain angle. We have some examples of circular motion. It's like wheels of a car or a bicycle. This is one of circular motion. Also, the Earth in its orbit around the sun is also an example of circular motion. The hands of a clock, a spinning DVD in a laptop, also the drum of a washing machine, and so many. So those are examples of circular motion. Example, this is a motion described by an object which is in circular motion. This is the center. You see, for example, an object is here. Now we find that the angle here is 0. The angle theta is 0 at this point, at the center of the circle. When it starts to move, is upward or downward, there is some angle made here. For example, when it reaches this point, let's say this point, we find that there is an angle. Also, when it comes at this point, we find that also there is angle. So in this case, we say that an object is describing a circular motion, a motion which is at certain angle. So this length from center to a point where the body is called arc length. Arc length is called, or is known as arc length. The angle theta through which the object has moved is known as angular displacement. The angle theta. This is known as angular displacement. And this theta is represented in degrees or in radians. So angle in radians, let us see how we can find angle in radians. We take, remember, from this body to the center, this is radius. So angle theta in radians is given by length of an arc over radius. This is length of arc. Sometimes we represent this as S. So we say theta is equal to S over R. So find that theta is simply a ratio, because S and R are both measured in meters. So this is ratio, because s and r are both measured in meters. It is unitless, just a ratio. Now let us see how radians relate to degrees. Let us see how radians how are radians related to degrees. If an object moves all the way round the circumference of the circle, if an object moves all the way around the circumference of the circle, let's say an object starts, this is the center, starts at this point, and it moves all the way around the circumference of a circle, we'll say it has moved in a distance of 2 pi r. It means the circumference of a circle is 2 pi r. So now we say angle theta is arc length over radius. So our arc length now to be 2 pi r over radius, so it will be equal to 2 pi. So our theta is 2 pi, but a complete circle contains, hence a complete circle contains 2 pi radians. But you know that a complete circle has 360 degrees, which will be equal to 2 pi. Now our pi will be equal to 180 degrees. 180 degrees pi radian. Or if you divide by 2, a half pi rad is equal to 90. Divide by 2 both sides. Or if you divide by 4 here, it will be a quarter rad equal to 45 degrees, and so on. So 1 radian is an angle subtended at the center of a circle by arc of length equal to radius of the circle. Here, 1 radian, say, is an angle subtended at the center. So define 1 radian. It means this is arc length. So how can find 1 radian? We can define that 1 radian, it means this arc length should be equal to radius. So if, because it's just a ratio of arc length and radius, if it's the same, to give 1 radian. So we say 1 radian is the angle subtended at the center. The center where circle by an arc of length equal to radius of the circle. So if the arc length and radius of the circle are equal, we say that is 1 radian because it's just a ratio. So from pi rad is equal to 180 degrees. If we divide by pi both sides, we have that 1 rad is equal to 180 degrees. So if you take 180 degrees over pi is 3.14, will approximately equal to 57.3 degrees. So this is how radian is related to degrees. So 1 rad is equal to 57.3 degrees. So this is how radians are related to degrees. So let us see one example here. If theta is 60 degrees, what is the value of theta in radians? What is the value of theta in radian? So what you have to do is just a relation of pi rad of pi rad is equal to 180 degrees. So how many radians we have in 60 degrees? It will have, which will be 60 pi rad over 1 degree x. So we're looking for x. So here will be equal to pi over 3 rad. So this is angle 60 degrees in radian. Let's see angular velocity. Because our object now is moving in a circle, it means there is a certain angle. It is moving in a certain angle. So what we have to use here is velocity, not a speed, because there is a direction which is angle. So our velocity now will be angular velocity because the body is moving in a certain angle, and this angular velocity is represented by a symbol omega w, which is known as omega. So our angular velocity omega will be equal to angular displacement which is s over time taken, which is theta. So our omega will be equal to change in displacement is n of theta over change in time. So this is how we find our angular displacement. The unit will be, the unit of angular displacement is radian over time, which is second. So the unit for omega is rad per second. This is a unity for angular velocity. So now let us see how angular velocity or how velocity is related to angular velocity. Relating velocity and angular velocity. Omega. So let us relate velocity and angular velocity. The velocity v and angular velocity omega. We say that the speed of an object traveling around a circle depends on two quantities: its angular velocity and its distance from the center. So when an object is moving in a circle, its speed depends on angular velocity and the radius. It means the distance from the center. For v will be equal to omega over r. So this is how velocity v is related to angular velocity omega. So let us find, just look this question. A toy train travels around a circular track of radius 2 meters in a time of 40 seconds. What is its speed? What is its speed? What is its speed? A toy train travels around a circular track of a radius 2.5 meters in a time of 40 seconds. What is its speed? So the speed here is v. So formulation of our v is equal to omega r. But in our question there is no omega, r is there. So we'll find omega. But omega is equal to change in angular displacement over change in time taken. So it will be our angular displacement here. Our angular displacement, because it's a circular track, to be 2 pi over time, which will be, our time is given 40 seconds. So it will be pi 20 rad. This is our omega. So now we have our omega and we have radius. So our speed will be pi rad times radius 2.5. So this will be our speed, which will be equal to, in meter per second.